Okay, so today we will see how to draw the graph of polynomial function. And we know that polynomial function may have any degree. Degree means the maximum power of the variable in its terms. So let's say we have been given one polynomial function like this, px equals x minus 1. So x plus 2 and x minus 4. This is a polynomial function and we need to draw this graph without using calculator. So there are certain steps that we need to do. Okay? First, we have to find the factors. If it is not given in factors, you have to factorize. Fortunately, we have taken only the factors here right now. Then mark the points. Second step is mark the points. Points means that zeros. Okay. Find so mark the points on x-axis. Third step will be to determine the end behavior. We will see one by one all of this. So we have to look into end behavior. Fourth, we have to take the multiplicity in account. So what is multiplicity? That we will also see. Multiplicity. And then starting from left hand side, we will draw the graph. So let us see one by one all of this. So end behavior. First, let us look into end behavior, multiplicity, and then we will draw this graph.
Okay.
End behavior. Let us look into this end behavior. End behavior. So what is end behavior? End behavior means what is the value of y when x tends to plus infinity or negative infinity. Okay. So there are certain rules that we need to understand. First of all, we are considering a polynomial function of leading coefficient an and degree n. So we know that any polynomial function can be written like this: an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 all the way up to a1x plus a naught. This is our general polynomial function. So here we will see that our leading coefficient is a to the power n, and degree of this polynomial function is n. Now, end behavior will be decided only by the leading coefficient and the degree. Other terms will not have impact on the end behavior. Okay. So how to go about this? See, if the leading coefficient, so first I will write like this. If our leading coefficient, this is the first scenario. So first scenario is if the leading coefficient is positive and degree is even, then what will happen if you go to plus infinity, that is when x tends to plus infinity, y will also tends to plus infinity. When x tends to minus infinity, y will still go to plus infinity. So if this is our if this is our xy coordinate, so we will draw like this, just one arrow here and here. Remember this arrows pattern. So for scenario 1, we will draw these two type of arrows. Okay. Now we will look into scenario 2. So scenario 2 will be an will be negative. Okay. So our scenario will be changed. So scenario number 2. So here an will be negative. An is negative. That is leading coefficient is negative, whereas degree is still even. So in that scenario, we will see that when x tends to plus infinity, y will always go to negative infinity. And when x tends to negative infinity, still y will go to negative infinity. And then now we will show our end behavior like this. Our end behavior will be like this one. This one will be our end behavior. So this is scenario number 2. Now we will look into scenario number 3. So scenario number 3 will be this we will change, this one we will change. So now our scenario will be if scenario number 3, if an is positive, that is if the leading coefficient is positive, but degree is odd, then in that situation we will see that when x tends to plus infinity, y will go to plus infinity. And when x tends to negative infinity, y will go to negative infinity. So that means we have to show the end behavior just here. One arrow like this and another arrow like this. Okay. So, okay. Yeah, just 1 minute. Okay. So this is scenario number 3 when leading coefficient is positive and degree is odd. Now, scenario number 4. We will simply change this one. So n will remain odd. And so now scenario number 4, and it is the last scenario. When leading coefficient is negative, leading coefficient is negative and n is odd, then what will happen that when x tends to plus infinity, y will go to negative infinity. And when x tends to negative infinity, y will go to plus infinity. So our end behavior will be represented in this graph like this one. We will show that this side arrow it is going and this side arrow it is going. So these are the 4 scenarios which are very, very important. Okay. Let us see a few examples of this end behavior.
Okay.
See, let's say we have one question that y is equal to 2x5 minus 4x4 plus 5x cube minus 10, let's say. Now we want to find out the end behavior. So you see, rest all does not matter. We have to figure it out which is our degree and what is the leading coefficient. So obviously we are more concerned about this. So here we can see that our leading coefficient is positive. What is the value that is not needed? So our leading coefficient is positive and the degree is odd. So if it is positive and degree is odd, so our end behavior will be somewhere like this. It will go like this. Something like this. Okay. So this particular information we will use to draw the graph of our polynomial functions. This is one part. Then another part is multiplicity. Let us look into that. So multiplicity means what is the power of each factor. That is multiplicity. While deciding the graph, it is important to find out the multiplicity. So let's say we have y is equal to x minus 2 whole square. So now x minus 2 is a factor. This is a factor and its multiplicity is 2 because its power is 2. So we will say that its multiplicity is 2, which is one even number. Now it can be also written as y is equal to x minus 1, y is equal to x minus 5. Let's say it is this one. Let us take another polynomial function. Y is equal to x minus 1, x minus 5 to the power 3. So it has two factors. This factor has multiplicity 1. This factor has multiplicity 3. These are called the multiplicity. Now,
Would it be multiplicity of 5 though?
no, you have to say multiplicity. Okay, multiplicity of 5 is 3, you can say. Multiplicity means what is the factor, what is the power of that factor. So we will say that x minus 5, this one has multiplicity 3. You can also say that x is equal to 5, which is a solution, which is a root. This has multiplicity 3.
Okay.
It's pretty much very simple. Like if you have y is equal to x minus 1, x plus, let's say x plus 4, 5. So can you tell me what is the multiplicity? What are the roots from this? Can you tell me what are the roots?
The roots are 0, 1, and -4.
Yes. So what is the multiplicity of 0? X is equal to 0?
It's 1.
1. Multiplicity of x is equal to 1?
1.
1. And here, -4?
5.
5. So multiplicity is 5, correct? Okay, this we know. Now, how this will affect the graphing? So, see, if we have, let's say on x-axis, we have marked one root. So let's say x is equal to 2. Now, maybe in the factor, so there are many factors, okay? Out of that, let's say we have x minus 2. This is one of the factor. It is possible that let's say y is equal to x minus 2 is there. So see, there are other factors also, but we are just concerned on just one solution, one root, that how the graph will be affected by the multiplicity. So if x minus 2, okay, so let us take here k, just one general idea, let us take k there. Multiplicity is k. Now if k is equal to 1, if k is equal to 1, which is the odd multiplicity, simplest odd multiplicity, so it is the odd multiplicity. So if k is equal to 1, then graph will cross it. Remember, whenever multiplicity is odd, so let me write here. Whenever multiplicity is odd, that means 1, 3, 5, 7, and so on, then graph will cross it. Remember, graph will cross the root. That means it will go like this. It will cross it. Simple. From which side it will cross, that depends on end behavior. That we will see later on. We will combine everything. But remember, if m is odd, then graph will cross that particular point. It will cross it. Okay. And if m is even, like 2, 4, 6, 8, and so on, in that situation, graph will bounce off. It will bounce off. What does it mean? It means that it will bounce like this. So let's say if our multiplicity is even for x is equal to 2, then graph will bounce like this. Or maybe from this side. But it will bounce. It will not cross. It will just bounce.
Okay.
Okay. Now, then what is the difference between if there is multiplicity 1 and 3? In both these cases, it will bounce, it will cross, right? But so in
Yes.
that scenario, what is the difference? So difference is that it will cross, okay, if we have m is equal to 1 and m is equal to 3. Let us talk about this with one example. So let's say we have y is equal to x minus 2, and we will draw y is equal to x minus 2 whole cube. We want to draw both of them. It is true that if you look into this particular graph, okay, first of all, can you tell me what is the end behavior for this equation? What is the end behavior?
So the leading coefficient is positive
Hmm?
and the degree is odd.
Hmm?
So then it would be like, do you want me to draw it?
Yes,
Okay. It would be like this.
perfect. So here we can take, so x is equal to 2, right? So we will take like this, x is equal to 2. Now here, see, always start from the left hand side. Okay. Now, what is the intercept? If you look into the intercept also, if you look into the intercept is negative 2. Okay. And x is also 2. So since it is a straight line, it will simply cross like this. It will simply cross like this, no problem. Just it will cross. This is a straight line,
Okay.
correct? Okay. Now, what
Yes.
about this? If you look into the end behavior, it is also same. That leading coefficient is positive and degree is odd. Okay. So how to draw it? So in this situation, x is equal to 2 is our one of the root. So technically speaking, it should come like this, right? Same thing. Okay.
Yes.
Now, since it has to cross here, now it will cross, but with certain broad base. It will make a little bit base like this, and then it will cross. See, our graph is approximate because we are not concerned about the scaling. If you look into the actual graph, you may get something like this also. That's okay, fine. You may get like this. Okay? Because we are not concerned about the scaling part. We just want to know how the pattern will look like. So y is equal to x
Okay.
minus 2 whole cube. Here you see, it is still crossing. It is still crossing, but it will be broad. Something broad, it will become flat. The point of cross and that point of intersection, it will become flat region of intersection. If it is x minus 2 to the power 5, it will become still more flatter, like this. Is it
Okay.
okay?
Yes.
Same thing happens with even multiplicity. In even multiplicity, what happened? That let's say if we have y is equal to x square. So this is even multiplicities, and we know this graph is simply like this. It will simply touch it. It will simply touch it. It will go like this. End behavior is this one. Now, if it is y is equal to x to the power 4, let's say, so in the same graph, we can represent this. This will become flatter. It will go like this. So this was a tangent, right? It was just touching like this. But as this power becomes more, then it will start flattening here. The base will become more broader, flatter, like this. Earlier it was just touching it, but now it will become a little bit flat.
Okay.
Okay, understood?
Yes.
Now, so fine. Now, having said this, we can combine everything to draw the figure. So, okay. let us see one by one. Our first example we will take y is equal to x minus 1, x minus 5, let's say it is square. This is our one example. So one by one, you have to tell me. What we will do is, first of all, we will draw the x-axis and y-axis like this. Okay. Then already factors are given, so we will mark the zeros. So this is x-axis, this is y-axis. So we will mark our zeros. X is equal to 1. Just so let's say this is 1, and let's say this is 5. Okay, now can you tell me the end behavior? Yeah, tell me end behavior.
So it is positive coefficient, and the first term has a negative multiplicity. I mean, an odd multiplicity, but the second term has an even multiplicity. So it would be positive and odd.
Yes.
So then it would go this way and this way.
Perfect. So here an is positive and degree is odd. So yes, it will be like this one. A little bit here we can do, because anyhow so we will do like this. Just one rough idea. This a broad type of arrow we will draw like this. Now starting from left hand side, we will start drawing our graph. So here you see x is equal to 1. Its multiplicity is odd. So that means it will cross. So it will cross. So you can make one straight line. Later on, we will make it curve. So it will cross it. Then x is equal to 5. Multiplicity is 2. So it will bounce off. This is the graph. Rough graph is this. It will bounce off. Simple.
Okay.
You have graphic calculator with you, right? Right now?
Yes.
Can you draw this graph there? Or do you have Desmos with you?
Yeah, I can have it on my computer.
Yes. So draw this graph and tell me how that actual graph looks like. Yes. So just see. So our scaling is little bit different, because we are not concerned about where this turning point is going on. We are just we are trying to find out what one rough idea how this graph will look like.
Do you want me to share my screen?
That will be good, so that we can check. This is our graph. Okay. Hold on. I have to stop my screen. Yes, you see? Same thing here. What we did. So you see here, this point is 1, this point is 5. So it has crossed this point, and at this point it has bounced off, and this is our end behavior. It will go like this. So our scaling is different. The actual graph is this. So we are obviously very close to the pattern of what we can expect. Is it okay?
Okay.
Good.
Yes.
Now let's look into some other questions.
Okay.
Okay. So now I am writing the polynomial function. You have to tell me one by one and draw the graph here itself. Let it be wrong or right, but you try it.
Okay.
So our polynomial function is, let's say, x x minus 2, x minus 6 cube. So yeah, try to draw it one by one. So let me, so here, it will be like this side only it will go. This is y-axis, this is x-axis. So tell me, what is the first step that we have to do? First step is to factorize. It is already given. Second step is to mark the points on the x-axis.
So then it would be 2 and 6.
Yeah, and 0.
Oh, yes, and 0.
So 0, 2, and 6. Then what is the second, what is the next step?
The next step is to determine the end behavior.
Perfect. So what is the end behavior?
The coefficient is positive,
Yes.
and the multiplicity is odd.
No, don't say multiplicity. You have to say degree. Degree means adding all the multiplicity, you will get the degree. Okay.
Oh, so I have to add 3 plus 1?
1 plus 1 plus 3. That is
Okay.
4, 5. So degree is 5.
Okay. So then it would be this.
A little bit this side you can do, because anyhow it has to cross here, na?
Okay.
Fine. So this is our end behavior. Now start drawing the graph. Just see how it will look like. So okay, just a minute. Yes, you can draw it there. Done?
Yes.
Okay. Okay. So here we can see this one. Just a minute. We will check this. Okay. So now, okay. So let me see. Oh my God, what you have done. Okay. You tell me where it will bounce, where it will cross. So it will cross everywhere, right? Because there is no even multiplicity. So it will cross everywhere. So it will go like this. It will cross it. It will again cross it. It will again cross it. It will go like this.
Oh, okay.
Just it will cross. Don't worry about the other thing. So how many turning points are there? If you look into this, there are 2 turning points. So turning points here are this one and this one. And from here you can say the behavior also. Like from 0 to 2 interval, this function, if this graph is increasing, then it starts decreasing. From 2 to 6 interval, graph is first decreasing, and then it is increasing. From 6 to infinity interval, graph is continuously increasing. From in negative infinity to 0, graph is continuously increasing. So you see, by just looking into this, you can tell many things.
Yes.
Okay, good. Now, okay, first you note down this, and then we will see one more example.
Okay, I finished.
Okay. So another example will be this one. Let's say y is equal to So we will do like this. Y is equal to x minus 2 square x minus 4. So yes, try to draw this rough figure, how this graph will look like.
So the leading coefficient is positive, and the degree is even. So
What is the
then
degree? What is the degree here?
it's 4.
Yes, correct. So what kind of, so what will be end behavior?
So the end behavior will be like this.
Perfect. Okay. Before that, you have to draw the, you have to mark the zeros here on x-axis. Yes.
So 0,
Hmm.
2, and 4.
Yes. Okay. No problem. Marking, we are not concerned about the scaling. So 0, 2, and 4, right? Now,
Yes.
starting from, so this is our end behavior. Okay. So can you try to plot this graph?
Yes.
Hmm.
So this degree is odd, so it will cross. And then this one is even, so it will bounce.
Hmm.
And then this one will cross.
Oh, perfect. Very good. You have drawn it. Yes. So maybe we have drawn like this. It may be something like this also. Okay. So we can find the exact graph also, but it will take time. But we are not concerned about that. We just wanted to know the turning point, where it is meeting, how it looks like. So yes, it will go like this. Correct. Okay, good. Then this one. Y is equal to, let's say, x plus 1 square x minus 2 3. Yeah, just try to do this one. So I'm writing down this particular graph here. So okay, try to draw this y and this is x.
So the leading coefficient is positive, and the degree is 5, so it's odd. So then the end, oh, first let me make the zeros.
Yes, there are 2 zeros.
Yes. Okay, so positive and odd.
Positive
then
and odd. Yes. So
this
starting
is
from
even.
left hand side. Yes.
Yeah, so this will bounce, and this is odd, so it will cross.
Now here there is a slight mistake. So it is true that this will go like this. It will bounce. It will simply bounce, right? But here comes, since it is cube, right? It is not one. So it will not pass through just as a single point. It will somewhat, it will make this type of structure, and then it will go.
Okay.
Understood now? Because now this that point of intersection will become flat while crossing x is equal to 2. So we cannot draw a straight line passing like this. That would be our answer had it been x minus 2 multiplicity 1. But now it is multiplicity 3. So it will become a little bit flatter. Is it okay?
Okay. Yes.
Now, you see here, we can say the end behavior. How many turning points we have here?
I think you have 3.
No, 2. This is 1, this is 1. We have 2 turning point. This we cannot take as a turning point. Here graph has not turned. Okay. Here graph has simply crossed it, but something like this, it has crossed. So it is not the turning point.
Okay.
Okay, good. Now, okay, I'll send you one worksheet where you have lot of this type of equations that you have to do it. Okay, write it properly and then you have to send me back. So, okay, now do this question. Y is equal to minus x, x minus 2, x minus 4 square. Do this one. So this is our x-axis. Let us take this as our y-axis. Now follow these steps and try to draw the approximate graph of this function.
Okay, so the first factor is 1.
Where is 1, Baba?
Oh, I meant, yeah, 0.
Hmm.
0 and then 2 and then 4.
Yes.
And then the leading coefficient is negative,
Yes.
and the degree is 4, so it's even. So the end behavior would be like this.
Yes, correct.
And the first one has an odd degree, so it crosses.
Yes.
This one will also cross, I think, like this. And then this one is even, so it just bounces.
Yes, perfect. Very good. Nice. It will go like this. It will bounce off like this. Now you write down this equation. Okay. You write down this equation in Desmos and see how this graph looks like.
Okay.
Okay. So yes, I'm stopping my screen. You share your screen. We will check how this looks like.
So negative x, x minus 2, and then x minus 4 squared.
Square. You see, similar thing we have seen that if you look into this one, it is crossing x is equal to 0. It is crossing x is equal to 2, but it is bouncing off at x is equal to 4. Okay.
Yes.
Now you just change here and write down x minus 4 to the power 4. We will see that it will still be same, but it will be flattened. Yeah,
Oh,
you
yeah.
see?
Yes.
Can you zoom it a little bit? You see this one. See the difference. Okay.
Yeah.
Earlier, when our power was 2, it was just touching. Just change here,
Yeah.
make it to 2, and see how it looks like. You see this one, it is just touching. But when it is 4, it will become flattened. Now you make 6. Instead of 2, make 6. You see this one.
Yeah.
Okay. And you make x minus 2 cube. X minus 2 cube. Cube, not square, cube. Yeah. Now a little bit, okay. Well, yeah, you see this one, how it goes like this. Earlier it was just crossing, but now it will become a little bit flatter and then it will cross.
Yes.
Okay, so that means virtually we can easily draw graph of any polynomial function if we know their factors and their multiplicities.
Okay.
Okay, it's good. Okay, can you quickly tell me in 2 minutes whatever we have learned today quickly?
Yes. So today we learned how to graph polynomial functions, and there are 5 steps. First, you have to get the factors, then you have to mark the zeros on the graph, then you have to determine the end behavior, then you have to find the multiplicity, and then you can draw the graph. So for the end behavior, the leading coefficient is an and the degree is n. And to find the degree, you have to add all of the factors' individual degrees. So there are four possible scenarios. If an is positive and n is even, then the arrows will go in both directions, like up. And then if an is negative and n is even, both arrows will go down. And then if an is positive and n is odd, the left arrow will go down and the right arrow will go up. And if an is negative and n is odd, then the left arrow will go up and the right arrow will go down. And then for multiplicity, it's just like the degree. So for like x, if y equals x minus 2 squared, the multiplicity would be 2. But if it was y equals x minus 2 cubed, the multiplicity would be 3. And then whenever m is odd, the graph will cross the axis, the x-axis, and whenever m is even, the graph will not cross it and it will just bounce off. And then whenever you have like a larger degree, the graph will be like more horizontal.
Yes, it will be flattened, right?
Yes.
Good. That's good. I'll send you one worksheet based on this. You can do it and you submit it tomorrow. Is it okay?
Yes.
Yeah. Okay, fine. So shall we leave now?
Okay, thank you.
Yeah. Thank you. Bye-bye.